What do we call that?
Pendulum.
Good. Now you can call it a pendulum if you want. I'm going to call it a pendulum because I've never seen a J in that word. I don't know what a pendulum is, but that's just what people call it. Okay? So, as I watch this swing,
Oh, is that part of it, or?
I'll do one at a time. Okay? So as you watch it swing, what is the obvious thing that we can measure about it swinging? Okay? What's the obvious thing? Boys, close your computers, please.
Change the.
What is the obvious thing that we can measure about it swinging?
Change of angle.
Oh, we could. Okay?
And like the string length.
We could measure the string length. We could measure the angle. We could measure the mass.
Calculate the tension.
We can't actually. That's something you know how to do. All right. What do we call the time it takes to go there and back?
Period.
So we know this. Okay.
So
The time it takes to go there and back is called the period. Now, we use a capital T to represent the period, and we measure it in seconds. And this is the time to complete one full swing. So from all the way here, all the way back to here, it's that time. Yes?
How do we measure the end of the period?
What do you mean?
Like that. Like how is it just from the release point, or is it?
It's the time it takes to complete one swing. So it doesn't matter where you start measuring it. So I can measure it at that far side all the way back to that far side. Or I can measure it from the bottom moving this way back to the bottom moving this way. Okay? It's one full oscillation. Okay? It's one full oscillation. So the period is something we can measure. Here's what I want to know. What are some things that we could change about this that might affect the period? Okay? What are some things that we could change about this that might affect the period? Tell me one.
Length of string.
Okay? Length. What's another thing?
The release point?
What's that?
The release point?
So like how far back do you pull it? So can we measure that in terms of like an angle? Okay. So she said initial angle. What else?
Uh-oh.
Good morning, 106. Yes. No problem. So these are the three answers that make some sense. Okay? These are the three answers that make some sense. And what we're going to do is we're going to try to verify these. Okay? We're going to try to verify these. All right? So let's do the mass first. So right now I have two of the same mass hanging on here. And if I let these swing, what should we notice?
They'll come back.
Is that cool? Do they go and come back? I mean, basically, they're next to each other the whole time, true?
Yeah.
Right? And that's within my ability to drop them at the same time and my ability to get their length the same.
And to eliminate some of the friction up there.
Yeah, they're both the same. Is that cool?
Yeah.
Now, here's what I'm going to do. I'm going to double the mass on the one that's close to me.
It's going to be the same still.
Maybe. That is definitely an option. I want to know which wins the race this time. Okay? So I'm going to let them go at the same time. Which gets back to me first? Is it the light one or the heavy one? This is twice the mass of the other one. All right? Check your neighbor now. See if your neighbor has an idea. Which one's going to get back first?
I remember there was something funky about it, like mass doesn't matter.
Yeah, I think it's going to be they're going to try to make it time.
Yeah. That makes
What do you think?
sense.
You're my neighbor.
That makes sense.
I forget I think we've used an equation before, but I feel like either they're going to be the same or the heavy one's going to come back first.
Well, you have chosen 2 out of the 3 options. All right, let's look. Ready? All right. You guys ready for this? Set? So I don't really know, like, I mean, just as a general idea, like, which one do you think is going to come back first?
Both are.
You think it's the same time?
Yeah.
This one is much heavier. The Earth pulls down on this one twice as much as this one.
Yeah, but there's also more mass to move.
So what? Does that make a difference?
Yeah, it's gonna be the same because I remember this lab from last year.
Do you?
It was like
No
something.
one remembers
funky.
anything from last year. Here we go. Ready? Set?
Yeah, it was something funky like that.
Okay. So, and the thing that I think is cool about this is, what do you notice about their positions relative to each other?
They're the same.
Yeah, and this is exactly the same. And Akila's right on the money here. He says, look, I know that the Earth pulls more on the more massive one, but because it's more massive, it also is harder to move. It's the same as the free fall acceleration. I'm going to triple up the mass here, and we're going to see.
Ooh.
Any different?
No.
Is that cool? All right. So does mass matter?
No.
Apparently not. Okay, apparently not. All right, let's go back to, let's look at this, let's look at the angle one. Okay. Now, I know if I release them from the same angle, what happens? They go there and back at the same time. True? But what if I let this one go at about half the angle? Now which one's going to get back to its original starting place first?
They're gonna be the
Okay.
same.
Is it the one that has to go far, the one that has to go short, or magically through divine intervention, somehow they make it back to their original starting
Well,
place?
it's gonna
at
be the same because the
time?
acceleration that is gonna be
Check
half.
your neighbors
Right.
now. The acceleration is different. If you pull it back farther, it's on a steeper angle. That's more.
No, that's what I mean. Like it's like half.
Half.
Like
Half.
arbitrarily, it's about half because it's half the angle. So
I don't
it would
think
stand to reason that would be the same.
It does not. No. That is not true. It does not stand to reason.
I don't know. I feel like I took the position last year or something of it being different, and then I remember being really wrong.
Just a real quick aside. Let me tell you what's going on for the weekend and then next week. So yesterday I completed, finally, sucking at life, the chapter 13 textbook videos. Okay, so these are my video solutions. They're kind of garbagey, but they will suffice. So the way you should do this is you should do the problem set. If you get stuck, then you should be like, I don't know where to go from here, that kind of thing. All right. Don't watch them and be like, oh, that makes some sense to me, and then just copy down what I did. That's not, there's no deep learning that goes with that. Okay? All right? And you want to get these problem sets in so that I can provide some feedback for you. All right? These are in the chapter, or these are in the week 31 folder. That's next week's folder. But that's just where they are. Hold on a second. So, here's the thing. We're going to start doing little AP practices. Okay, they're free response practices. And you're just going to do one a night. It should take between 15 minutes and a half an hour. Right? It should take between 15 minutes and a half an hour for you to crank one of these out. I want you to do this one for Monday. We're going to look at the answer on Monday. All right, you're going to use the rubric to grade your stuff. Does that make sense? If you don't do it, you can't use the rubric. You're literally getting nothing out of it. All right? Take 50 minutes or half an hour. Do it in earnest. Come ready for Monday. On Tuesday, we're going to do this one. On Wednesday, we're going to do this one. On Thursday, we're going to do this one. And on Friday of next week, we're going to do this.
That's the wrong Friday date.
It is the wrong Friday date.
That's why I got panicked because I forgot.
Oh, no, is that why you did this one? I was like, what?
So for the reassessment on the chapter 13 multiple choice, should we just wait till next week to do that?
Yeah, because I want to look at the
Okay.
answers.
Yeah.
Okay. I want to make sure that there's no questions on the version. All right, so there we go. So do this, okay? We're going to grade it with the rubric. We're going to see where you guys went right and where you went wrong, and then we're going to start getting some practice with the rubric. Because I think today's the 23rd. So your AP test is in a month, right? A month and a day. It's the 24th. Yeah? So we got a month left, which I feel really great about, actually. I feel fantastic about it. But we need to get some real practice in, so make sure you do this. Yeah?
AP exams, I think, end on the week of, well, the 28th is the last day, I think, that week that our test is. Do you know how long seniors have school after that?
No. There has literally not been a decision made. We've been asking as teachers, and the decision makers have not made a decision.
Like, they haven't even said it yet.
No, they don't know.
But we should graduate early, or they don't finish early.
Yes, but I don't. We literally have no idea.
When does normal school end?
The 18th of June.
So that's 3 weeks.
So for underclassmen, so your like graduation will be like late that week, right? So like either the 16th or 17th of that week will be like graduation, like the actual.
I thought it was the 9th or 10th, I think.
Oh, is it the week before that?
Yeah,
Was it really?
yeah.
Oh. Well, then probably then, like in the original schedule for school, last day for seniors was probably the Friday before that. So
That first week.
we would have Memorial Day on a Monday, and then you're probably scheduled to have school Tuesday, Wednesday, Thursday, Friday of that week.
So
For exams.
So why has that changed? Because we don't have finals?
Yes.
Ah, okay.
But because there's no final exams,
Why would
I think people are like, well, what
Mark time.
are we doing?
Yeah.
And the state lifted the requirements on the school year minutes, so,
Oh, okay, yeah.
yes.
So for this class's all intents and purposes, what are we gonna do after the AP exam?
Nothing. Well, that's literally the end of the class. There's nothing after that.
Can't we learn stuff?
No. Not at all. I mean, I'm sure you can, at least I'm hoping you can, but I'm not doing anything.
Trebuchet.
No, you're done. Dishes are done, man.
You do card tricks the whole time.
Mr. Vernelli,
Will you teach us card tricks after
Just say-
that?
I thought you said cartwheels?
Ooh,
She goes,
snap
let's do cartwheels the
circuits.
whole time, like cartwheels?
Card tricks.
Card tricks. Yes, I will teach you as many card tricks as you like.
Snap circuits?
Yes.
If we are in school for any time after the AP exam, since we could do the boat race this year, can we do an egg drop?
Yeah,
Like the regular physics did?
yeah,
Sure, you guys want to do egg drop? We can do that.
yes.
That's fine.
And this time we can use parachutes?
No.
Aw,
Let's do people drop, all right? Let's do people drop, then you can use parachutes. That sounds very fun.
alright. I will
All right.
volunteer as tribute.
What did we decide? If I drop them from the same angle, they swing the same, true? But if I drop this one from here, which one's going to make it back first?
It's gonna be the same. Cause the distance it has to travel also got cut in half.
Yeah, but it's got to go a much shorter distance.
That's what I just said.
So it should get there and back sooner.
No, because it's going to have less speed because it's less of an
This
angle.
doesn't make any sense. Let's check.
Yeah.
Same time?
Yeah.
Is that weird? Let's switch.
The math checks out.
Oh, so that turns out to be true, even if I just give it a little swing like that. Do they swing there and back in the same time?
Yeah.
They totally do. That is a crazy bit of physics. It is a crazy bit of physics to think that as these swing, and even if you think about like this idea, that the distance that's swinging back and forth is actually decreasing over time, but the time it takes to go there and back is always the same.
Yeah.
Is that weird? I think it's very weird. So there's two things we need to know. One, mass, not a factor. Angle, not a factor. Do you think length is going to be a factor?
I think so.
Right? I mean, something's got to change, right? So, if I shorten this one up, okay, and I let this swing,
Yeah.
does it go there and back in less time?
Yeah.
It
About
absolutely
like
does.
two things for one thing.
So, does length matter?
Yes.
It does 100%. And what we're going to need to do is we're going to need to take some data and figure out in what way it matters. Okay? We can do that on Monday. That's okay with me. If you're behind on stuff, please catch up this weekend. And you have to do quiz A before Monday, and you have to do the 2010 number 1 before Monday. Get those done so you can participate in the class. You are holding us back.
We're just like notification stuff. Whatever you want.
Cardboard there.
I'm talking like plywood, like box, and just like,
Wait, quiz day is not late, right?
Yeah, you had to do it for today.
No, I did it for today. That's right. It's not
Okay,
late.
Mark, come here a second. So this is good. This is good. This is good. Here, when you plugged in the R value, you use the distance from the surface and not the distance from the center.
So would the answer would have been negative or?
The answer is absolutely negative.
Okay, that was a main question. So
Yeah. So this is wrong here, because you used the wrong answer. But yes, so the gravitational potential energy of objects in orbit is negative. Because the gravitational potential energy is almost always larger than the kinetic energy.
Okay, I already did the B one and I think I messed that up again.
Okay.
So is there a C one?
Oh, yeah. I'm going. Yes?
I have the same sort of, I turned it in this morning,
Okay.
and now that I'm looking at these values, I did something wrong, because I got really big values.
All right, well, I'm sure I graded it and put some feedback on it.
All
So
right.
look at that and then try the new one, all right? If you're
All right.
stuck, I can help you with it.
All right.
yes.